The main goal of this unit is to be able to translate any of these polynomial equations into at least a somewhat accurate visual representation, like your graph. Okay, so I can already kind of visualize what this looks like. This is a parabola because it's a quadratic. It has a degree of 2. The parabola is opening upwards because we have a leading coefficient of 1. Okay, that's great. That kind of gives me a general shape, but I mean, it could be floating anywhere on the grid. Like, give me more information. We do that by digging a little bit further. So factor, set it equal to 0, and then solve. All right, now I have my x-intercepts. So this parabola is not just floating around. It actually has a location. It cuts across the x-axis at -1 and 2. Now, here are some tips. First of all, I got these two numbers by taking the opposite of the numbers inside the brackets. Tip number 2, always set it equal to 0. Don't forget that. A lot of people do. You have to set it equal to 0 because you can't solve for x unless, of course, it equals to something. And then also, any of your x-intercepts should have a y value of 0. Okay, so a lot of people forget that on tests and quizzes. Don't make the same mistake. Now, if we go on to something bigger, a larger polynomial, this is pretty good. They've actually already factored for us. Fantastic, I don't have to do that work. They've also set it equal to 0. That means all I have to do is solve for the x-intercepts. Opposite of these numbers are going to give us our x-intercepts. Tip number 3, make sure they're in order from smallest to largest. You won't get marks taken off, I don't think, depending on your teacher, but you have to make sure that these are in order because it's good practice for when you start to make your interval charts. Okay, so that's another tip. I'm full of tips. All right, what if they've actually not factored it for us? What if they left it in standard form? Well, that's a bummer because now you got to factor it yourself. Okay, so this is how you factor. Figure out your first factor. You do that by taking this last number and you're going to think of all the factors that it has. So what can 6 be divided by? Well, 1, 2, 3, and 6. Okay, now not only those numbers, but also the positives and the negatives of any of those numbers. So positive -2, positive -3, and so on. What you want to do, tip number 4, is you want to start with any of the smaller numbers. They're usually your factors. Now, sometimes they have the bigger numbers, but not all the time. I'm telling you this through experience. They almost always pick the smaller numbers. Okay, so what I'm going to do is I'm going to start with the +1. Take +1 and sub it into your x's. Then figure out your answer. F at 1 gave me -8. Now here comes the remainder theorem. Remainder theorem says that if I actually did the division, I did long division with this guy as my dividend and x -1, remember opposite of this, as my divisor, I'm going to get a remainder of -8. That means that this is not going to be a factor because I got a remainder. So you know what? Cross that out. We're not going to do the +1. Let's try the next one, -1. So sub in a -1 into all of your x's. F at -1, okay, gave me a 0. That means if I did the long division with x + 1 as my divisor, I would have gotten a remainder of 0. So you know what? I'll show it to you. Here is the long division. I used x + 1 as my factor, and then you know what? That's actually the first bracket we have then. We just got to figure out the other two. So once I did my long division, okay, remainder 0, just like it said right there. And there's my quotient. That quotient is basically these two brackets put together. So what I have to do is start breaking it down. So take a look. Here was our original polynomial. I've broken it down. I found one of the factors, and then the other factor is this guy right here. Then now that it's a quadratic, I mean, it's a simple polynomial, simple trinomial, I can break it down into 2 very easily. I don't have to do the long division. Okay, so there you go. I got my red and I broke down my 2 greens. Okay, so I'm not going to go further. I'm not going to set this equal to 0 and solve for my x-intercepts because they didn't ask me to. They only asked me to factor completely. If they say to solve, that means that you have to do this process and find the x-intercepts. Okay, so let's get into that a little bit. Here's a reminder. set it equal to 0 after you've already factored it. Then you can solve for your x-intercepts. One more step, make sure that it's in order from smallest to largest. So these are all your x-intercepts. Here's a longer note. You can pause the video and read through it. It's just saying the exact same thing. And then this is going over the steps again. Okay, so let's see some examples now. I'm not going to show you both. I'm probably going to do the harder one, which is the bottom one, because I'm pretty sure that's the one that you want to see. But I'm going to show you the work for the first one. Here's what are we on? Tip number 5, I guess? Yeah, lots of tips. Bring all this to one side so that you get those equals to 0 on the right-hand side. Okay, so it has to equal to 0 for you to solve. And notice they did ask you to solve. Okay, so what you're going to do is you're going to, let me get out my highlighter, take factors of this guy, 1, 2, 3, and 6, and then start subbing it into your x's, and I found one. -1 works, so I put x plus 1 as our factor. Here's the work right here. See, -1 worked, it gave me a remainder of 0, so x plus 1 must be a factor. Then you put x plus 1 as your divisor and start to divide the entire polynomial. Long division, you should get a 0 as your remainder, and then this is our quotient. Okay, so since this is a quadratic, we could always break it down, and then I have something like this. So there's our quotient right there, and you can easily break it down through regular factoring. Set it equal to 0, and then solve for each of the brackets, from smallest to largest. Okay, so this is the one that I said I was actually going to go through. Holy cow, it's a quartic. Okay, so we should expect possibly 4 brackets. Okay, so take this back number, positive 18. Now let's see, numbers that multiply to 18. Positive -1, positive -2, 3, 6, 9, and 18. And I'm going to start off with the ones. So what I did was I tried +1, and I think it didn't work, so I tried -1, subbed that in, and I got 0, which means that x plus 1 is a factor. That's why I put it here as a divisor, and then I start to divide the entire polynomial. So here's a long division, and there's my quotient. Sorry, I'm going to move up and down a lot for this slide, just because, well, it doesn't capture everything. So here's that first divisor, and then there's our quotient. What we want to do now is break this guy down a little bit further. So what I'm going to do is I'm going to do the process again. Take this 18 at the back, think of all the factors, 1, 2, 3, 6, 9, and 18, and then start subbing it into the x's. Once I find a good number that works out and gives me a remainder of 0, that's going to be my factor. So I think +2 ended up working. This guy, remember, that's just your +1. That's from before. Okay. All right, so let's see this solution. You're going to have to do long division again. Okay, so like I said, I subbed in 2, and then I got x minus 2 as my factor. So I put that right there, start breaking down that cubic. This is what I got as a quotient. So then I'm going to move up again. Okay. X squared minus 9 is going to be my quotient. So here is that second factor. This is my first factor. And then I can always break this down now that it's a squared. So it's just a simple trinomial. I can break it down into these two through a difference of squares. It's set as equal to 0 already. That means I can start to solve. X equals to -1, +2, +3, and then -3. And everything's in order. So I've solved, and these are my x-intercepts. If I decide to graph this, these guys would be the points where my graph would touch the x-axis. Now, it might not always touch the x-axis, and here's an example. So example number 2, explain why the following polynomial equation has no real solutions, no x-intercepts. And that's because notice that this is a degree 8. It should be kind of like a W shape, or it could have many bumps in the middle. So it's pointing upwards. It has a positive leading coefficient, but then notice that there's only positives in between each of the numbers. So whatever my x values are, they're never going to be negative. which means that this side of the equation will always be a positive. There's no way that it would ever equal to 0. So you could have some graphs that don't have x-intercepts, and this is just one other, I guess, tip. There you go, tip number 6, okay? So tip number 6, you might not always get an x-intercept, and you can kind of tell by the exponents and also your symbols in between. Okay, so now we're actually getting closer and closer to getting a very nice, accurate graph, and this video was all based upon your x-intercepts, an extra feature.